Good.
Bonsoir à tous. Pour éviter les problèmes de traduction douteux, je vais tout faire en anglais. Hello everyone. Thank you very much, Charles and Tony, for inviting me tonight, and all the Heuritech team for organizing this event. Thanks a lot for NVIDIA and Facebook for sponsoring the event, and thanks to Yann LeCun for being among us tonight. We appreciate that. Thank you. I am Gregoire, and I'm the CEO of Phoenixia. At Phoenixia, I did my PhD in the University of Montreal under the supervision of Joshua Bengio. I did my PhD in machine learning and deep learning. During my PhD, I had the chance to work at Microsoft Research and Facebook Research. I also founded my first startup in 2012. And we are tackling the problem of fraud detection for a big online retailing company in South America. After my PhD, I got a very nice offer from Google, but I decided to start my second company and to turn it down. So at Phoenixia, we are a team of deep learning experts. We work with businesses ranging from startups to big companies. We come along with your team on short-term or mid-term ambitious projects involving deep learning, and we code very specific solutions to your need. At the end of the process, we don't grant you a license, you own the solution. And since we don't want to deliver you a black box, we try to bring as much as possible the deep learning knowledge so it remains in-house after we leave. We also work with investors, we do due diligences, and we take up also advisory roles. Today I would like to talk to you about ways to improve your search engine. So what is a search engine? Google. So you type a query, and then the goal is to rank a set of pages among many pages to make the page the most relevant, the top one, and the less relevant, the last one. So this is Google. Google is very good. Now your search engine, if you just started an online retailing company yesterday, and you're going to start from scratch. You have a database of millions of products, because you want to sell many products. You're going to select a few text attributes of your products, and you're going to aggregate them into one signal. And then you're going to use TF-IDF to compute a representation. And there is no learning involved at all. It's just the frequencies in your corpus that's going to determine the quality of your presentation. And first of all, what you can see here is that your search engine only uses one signal, while Google, it's known that Google uses hundreds of signals. And the TF-IDF signal is a poor signal, and Google uses hundreds of good signals. So let's think about ways you can improve your search engine right now for free without paying for anything additional. You can use all the signals you already have at hand. So what I mean at hand is everything you have about your products. You want to sell something that looks beautiful, you have beautiful images, use your images. You have textual information, attributes, let's use all of that. And then you can use the user feedback to learn the representation that tells you what your customer wants. So the customer arrives on your website, type a query, and then click on a product. After that, you have a conversion or not, but basically what your user is telling you is that when I tell you that, I want that. So why not using it? And it's free. So let's get more technical. First, we'll see how we're going to parameterize using deep learning architectures to map into a joint semantic space between your products and your query. Then we'll see how we can learn those representations using click-through data. And then we'll go along a few results that were obtained at Microsoft Research recently. So let's talk about deep learning models for that. The goal here is you want to learn a semantic space. So you have a query, let's say 27 inches and then 1 meter, and then you have all your products, and you want to map your query and your product into a joint semantic space. In this semantic space, you're going to compute a similarity measure between the query and the product. And obviously, if the product is 27 inches in monitor, you want the similarity measure to be high. If it's a vacuum cleaner, you prefer the similarity to be low. Then the big question is how you learn that projection. So, first of all, you know that you're going to have text information in your products, and the query is composed from text. So, most of the people here, and like in the last presentation, people use word embeddings, use like word to vec, these kind of approaches. You can also use letter trigrams. So rather than having a word that's represented by a word embedding, you get a word that's represented by a sum of letter trigram embeddings. So for example, if you have the word cat, you can decompose that word into 3 trigrams and then get its representation into a bag of trigrams. So you will have pound CA first trigram, then CAT, and then 80 pound. So this is for one very simple word, but then you can imagine having a sequence of words and then encoding the whole sequence into a bag of letter trigrams. So this is at the very bottom level. Then we're going to plug that into a deep learning model, a deep neural network. You're going to have, like at the very bottom, this letter trigram representation for your textual input. And then you're going to stack a few layers, as many as possible. The slide was too small. And then you're going to project this letter trigram into that semantic space. So the top layer represents the representation. This is where you project. Then you can use different deep neural networks. You can also use a convolutional version, where rather than having only your whole sentences projected into a bag of letter trigrams, you want to go more like finer. You want to take a sliding window and consider like several words and map those words into this space. And if you want to learn like long-term dependencies or mid-term dependencies, it's better to take a recurrent neural network. So in that case, you're gonna still use the same letter trigram representation, but then you're gonna have every hidden layer in your representation is gonna take as input the previous hidden layer. Then let's talk about images. So you can use AlexNet or BGG16, depending on how much time you have. Here is a picture of AlexNet. Again, the picture of BGG16, I couldn't find one. It's too big. So on the left side, you put your image. Then you're going to project your image through this convolutional neural network. And then the only thing you're going to have to learn is a projection matrix into your semantic space. So the parameters of the convolutional neural network remain fixed, but then you learn the parameters of your projection. So the semantic space at the end is shared between your query, your product images, and your textual information. The good thing about plugging the images, if you have very high quality images and they don't depend on your user, it's going to make your semantic space much richer. So if you only have textual information, then you can navigate and look at the nearest neighbors. But then if you have images, then you're going to have products that look similar to get closer together. And this can give like a very nice improvement. Now we have like all the parameterization of our models, and now we want to fine-tune them. So we're going to do that using click-through data. So first of all, what is click-through data? If we get back to the previous slides, we have like this query, these pages, and then the user is going to click on the second one. So this is something that you can start to load tonight. You go, you take all your users, they type queries, and then they click on products. Then you add that to your dataset. So you have a dataset that's composed of queries and pages, or products, or documents. So in that case, the query was deep learning meetup, and I click on the page deep learning meetup pound 4. Then, at the time of learning, You take one sample in your dataset. So we have the query, we have the product, as shown in the previous example. And you're going to sample random products. Then you're going to compute in parallel on an NVIDIA GPU card, Pascal 100, a semantic representation of all those queries and products. Then you compute a similarity in that space, and you're going to make sure that the similarity between the query and the product, so the similarity of this sample of your dataset, is higher than the similarity of the query and random products of your training set. So you can do that through various techniques. You can use a hinge loss and try to maximize the margin between the positive similarity and the negative similarity. You can also put those values into multinomial logistic regression and then maximize the log likelihood. There are many options. And yeah, so you just want to make sure that those similarities are of the positive sample are higher than the negative ones. Then let's go through some results to conclude that. So on Ping, when I was at Microsoft Research, we measured the NDCG on an evaluation set. So NDCG is a non-discounted cumulative gain. It's a measure used to evaluate ranking algorithms. And the evaluation set was composed of 12.5K queries. And in average, we had 60 pages per query ranked by human experts. And the human experts are going to say, okay, given that query, I think this document is highly relevant, poorly relevant, very poorly relevant. And then we're going to average several human experts and then beat this data set. Then, if we report the results of NDCG at 1, so we only consider the first product that's given by our algorithm, or at 3 if we consider the top 3, or at 10 if we consider the top 10. Then we first compute the accuracy of our baseline on this dataset. So TF-IDF or BM25 got this kind of numbers, and then we use the level trigram combined with a deep learning model. And so we got these little improvements from 0.5% for an NDCG at 1 to about 3% for the top 10. Then if you go to a much finer level and you want to consider the convolutional version, then you got gain from 1.6% to 4%. And then if you're using a recurrent version, like LSTM in that case, you can expect even higher gains. Those gains are on a very complex task. It's web ranking, it's pages, there is a lot of content, it's very hard. But most of the time on a simple data set where it's just products that you're trying to sell, sometimes just getting a tick model is enough. Then you're going to try to get like a convolutional model, but then you realize that the average number of words in your products and in the queries is less than 3, and there is no need to go further than that. And I don't talk about the recurrent version because you don't need to handle dependencies that go further than 15 words. So to conclude, I presented today a way to learn a very powerful representation that's very different from computing TF-IDF. TF-IDF, there is no learning, it only depends on your corpus. Here you learn a powerful representation, and this representation is going to encompass all the information you have about your products: the image, the description, the summary, the price, the color. And you're going to learn this representation using user feedback. So basically you're going to learn something that your user is expecting to happen on your site. If you want deep learning in your business and you think that your search engine could be better, feel free to reach out to us at phoenixia.ca/contact. If you're looking for a job, we're hiring too. And I'll be here afterwards, so feel free to come to me and we can talk. I'll be happy to hear from you. Thank you very much for your attention and enjoy the last talk.
Merci Grégoire. C'est des questions en français ou en anglais? Hi. Do you learn the representations once and for all, or does it evolve when you get user feedback?
So it depends most of the time, since people don't use this information. When you arrive with companies, they just realize that, oh, like my user is working for me and for free, and I didn't know that. So first they start to log, and then the more data you have, the more you can train the model. After a few months, you're going to have like 1 million samples, then after a couple of months, you're going to have 20 millions, and then you keep gathering, and then you select like the samples that are like the most relevant for the task you're trying to solve. But there is no active process of learning. You just take your data set as is, then you try to filter it and make it as clean as possible, then you learn your model, and then you deploy it.
Okay, so no active learning.
No active learning.
Okay.
Feel free to come and work with us if you want.
Any more questions?
I wanted to know why you choose characters 3 grams and not, why is it a 3 gram and not 4 gram, or why are you using characters?
Yeah. So unigram doesn't work. By gram there is a collision rate that's very high. So when I say collision rate, like if you look in the dictionary and then you try to project words with the letter of like by gram, so you just take 2 letters, then you're going to have many words that are going to end up with the same representation. But if you use trigram, then the number of collisions, I think on a 500,000 dictionary of words, you have like 500,000 words in your dictionary, and you're going to have only 22 collisions. So basically it's a way to avoid the collisions. You don't want to have like words that are like very similar in terms of letter trigram, but have a very different meaning to be collapsed into the same word. You will lose a lot of information.
Hi.
Okay. So
you were explaining that you were logging the query and the link on which the product on which the user was clicking. Is there a reason why you wouldn't log the ones on which the user didn't click?
So in this framework of training, you sample at random. I would say, so there is no ability to log that for learning. But then if you're the company and the user types a query, and then you show him results and the user doesn't click, if it's not because the user went out for a coffee, it's because your results were not good. So you may want to log this data to evaluate the quality of your search engine. That would be like a good reason to log that. But then, in the framework of learning, in that sense, there is no utility at the moment.
All right, one last question maybe?
Thank you. I had an unrelated, non-technical question. Where are you based?
Good question. So I ended up with the French administrative process to start a company here in Paris. It ended up this morning. This company is based in Montreal, where I have experience. And so, depending on where you are, if you want to be in North America, if you want to be here, well, I have 2 companies now.
Great, thanks.
Thank you.